It is page number 4040. Example number 11. Examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 and 2x plus 4. Solution. The 0 of x plus 2 is minus 2. Let px is equal to x cube plus 3x square plus 5x plus 6 and s x is equal to 2x plus 4. Then p minus 2 is equal to 0. So by a factor theorem, x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. It is page number 41. Again, s minus 2 is equal to 0. So x plus 2 is a factor of 2x plus 4 also. In fact, you can check this without applying the factor theorem, since 2x plus 4 is equal to 2 into in bracket x plus 2. Example number 12. Find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Solution. As x minus 1 is a factor of px is equal to 4x cube plus 3x square minus 4x plus k, p1 is equal to 0. Now p1 is equal to uh, P1 is equal to 4 to the power 4 into 1 to the power q uh, plus 3 1 square minus 4 into 1 plus k, or you can say 4 plus 3 minus 4 plus k is equal to 0. That therefore k is equal to minus 3. We will now use the factor theorem to factorize some polynomials of degree 2 and 3. You are already familiar with the factorization of a quadratic polynomial like x square plus lx plus m. You had factorized it by splitting the middle term lx as ax plus bx so that a into b is equal to m. Then x square plus lx plus m is equal to x into a both in bracket into x plus b both in bracket. We shall now try to factorize quadratic polynomials of the type ax square plus bx plus c, where a is equal to not 0 and a, b, c are constants. Factorization of the polynomial ax square plus bx plus c by splitting the middle term is as follows. Let its factor be px plus q and rx plus s. Then ax square plus bx plus c is equal to px plus q into rx plus s is equal to prx square plus in bracket ps plus qr into x plus qs. Comparing the coefficient of x square, we get a is equal to pr. Similarly, comparing the coefficient of x, we get b is equal to ps plus qr. And on comparing the constant term, we get c is equal to qs. This shows us that B is the sum of two numbers PS plus QR whose product is PS into QR is equal to PR into QS is equal to A into C. Therefore, the factor AX square plus BX plus C, we have to write B as the sum of two numbers whose product is A into C. This will be clear from example number 13. Example number 13. Factorize 6x square plus 17x plus 5 by splitting the middle term and by using the factor theorem. Solution 1. By splitting method, if we can find two numbers p and q such that P plus Q is equal to 17 and P into Q is equal to 30, then we can get the factor. So let us look for the pairs of factors of 30. Some are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Of these pairs, 2 and 15 will give us P plus Q is equal to 17. So 6x square plus 17x plus 5 is equal to 6x square plus 2 plus 15 in bracket into x plus 5 is equal to in bracket 3x plus 1 into 2x plus 5 in the bracket also. Solution number next solution is solution number 2 using the factor theorem. So 6x square plus 17x plus 5 is equal to 6. You can take outside and in bracket you can write x square plus 17 by 6x plus 5 by 6 is equal to 6 into px. Say if a and b are the zeros of px, then 6x square plus 17x plus 5 is equal to 6 into x minus a into x minus b. So a by b, a into b is equal to 5 by 6. Let us look at some possibilities for a and b. They could be plus minus 1 by 2, plus minus 1 by 3, plus minus 5 by 3, or plus minus 5 by 2, plus minus 1. Now p1 by 2 is equal to not 0, but p minus 1 by 3 is equal to 0. So x plus 1 by 3 is a factor of px. Similarly, by trial, you can find that x plus 5 by 2 is a factor of px. Therefore, 6x square plus 17x plus 5 is equal to in bracket 3x plus 1 and 2x plus 5 in other bracket, both multiplied. For the example above, the use of splitting method appears more efficient. However, let us consider another example. Example number 14. Factorize y square minus 5y plus 6 by using the factor theorem. Let py is equal to y square minus 5y plus 6. Now if py is equal to y into a in bracket into y into b, you know that the constant term will be a minus b. So ab is equal to 6. So to look for the factors of py, we look at the factors of 6. The factor of 6 are 1, 2 and 3. Now P2 is equal to 0. So y minus 2 is a factor of py. It is page number 43. And also P3 is equal to 0. So y minus 3 is also a factor of y square minus 5y plus 6. Therefore, y square minus 5y plus 6 is equal to y minus 2 in bracket into in bracket y minus 3. Note that y square minus 5y plus 6 can also be factorized by splitting the middle term minus 5y. Now, let us consider factorizing cubic polynomials here, and a splitting method will not be appropriate to start with. We need to find at least one factor first, as you will see in the following example. Example number 15. Factorize x cube minus 23x square plus 142x minus 120. Let px is equal to x cube minus 23x square plus 142x minus 120. We shall now look for all the factors of minus 120. Sum of these are plus minus 1 plus minus 2 plus minus 3 plus minus 4 plus minus 5 plus minus 6 plus minus 88 plus minus 10 plus minus 12 plus minus 15 plus minus 20 plus minus 24 plus minus 30 plus minus 60. By trial we find that p1 is equal to 0, so x minus 1 is a factor of px. Now we see that x cube uh, minus 23x square plus 142x minus 120 is equal to x cube minus x square minus 22x square plus 22x plus 120 x minus 120 x square in bracket x minus 1 minus 22x in bracket x minus 1 plus 120 into x minus 1 in bracket is equal to x minus y in bracket into in bracket x square minus 20x plus 120. By taking x minus 1 as common, we could have also got this by dividing px by x minus 1. Now x square minus 20x plus 120 can be factorized either by splitting the middle term or by using the factor theorem. By splitting the middle term we have x square minus 20x plus 120 is equal to in bracket x minus 2l into x minus 10. So x cube minus 23x square minus 142x minus 120 this is plus 142x minus 120 is equal to in bracket x minus 1 into x in bracket x minus 10 into in bracket x minus 12. Now exercise 2.4 is there. You have to solve all the question of this exercise. Next point will be 2.6 algebraic expression.